Okay, hi everyone. Good morning. Morning for me anyway. And I'm just going to take you through trigonometry at AS homework 1, this first one, which is mainly about sine and cosine rules, exact values in trig. Let me just, before we start, remind you of the exact values. Sine 30 is a half, which means cos of 30 must be the other one, root 3 over 2. Sine 60, they go the other way around, and cos 60. You just swap them over. So that one's going to be root 3 over 2. That's going to be a half. The tans you can work out by dividing them, because sine divided by cos is tan. So tan of 30 must be 1 over root 3. Cos of tan of 60, sorry, must be root 3 over 1, which is just root 3. And generally speaking, tan of 90 minus x is the reciprocal of tan of x, by the way, as well. The only other ones you've got to remember really are sine of 45, cos of 45, and tan of 45. Sine of 45 is 1 over root 2, which is also what cos of 45 is. And tan of 45 will be 1 over root 2 divided by 1 over root 2, which is 1. Okay, well worth remembering those. And you've got the sine and cosine rule. Let's just quickly write those down as well, because this is basically what we're going to be using here. Okay, sine A over A equals sine B over B equals sine C over C. This only works for a triangle where the capital letters are opposite the little letters. So what I mean by that is any triangle, it doesn't have to be right angle, but if that's capital A, that's got to be little a. If that's capital B, that's got to be little b. If that's capital C, that's got to be little c. So you have the sine rule, and you have the cosine rule. A squared is b squared plus c squared minus 2bc cos A. And these are easily proved, well, quite easily proved, semi-easily proved, let's say. And this is just a rearrangement of this one. If I add the 2bc onto this side and take away the a squared, I'd have b squared plus c squared minus a squared. Ooh. But then if I divide by the positive 2bc, if it's on the other side, it's positive, then I get that. So those are the formulas you need for this homework and results. Okay, in a triangle ABC, AB is 5 root 2, BC is 8, angle B is 60. Find the exact area of the triangle. I've just reminded myself of another formula we need. Area is a half AB sine C. But really what this formula is, and don't worry so much about the letters. Look at what they really mean anyway. This means you need two letters and the angle in between. Look at that. BC, AB sine C. But you could use AC sine B or BC sine A. It really means you need two lengths and the sine of the angle in between. The cosine rule, you need all three lengths to find the angle, but make sure the one you're taking away is opposite the angle you're looking for. Or, with a squared is b squared plus c squared minus 2bc cos A, what they're saying there is to find the length, you need an angle opposite that length and the two sides either side of that angle. Okay, right. Anyway, I've been waffling on enough. Let's get on with it. So when I get a question like this, I like to draw it. Actually, it doesn't have to be a perfect sketch. Let's just draw it like that. So label it ABC. AB is 5 root 2. BC is 8. And angle B is 60. Then you can see straight away what's going on. So to find the area is going to be a half times 5 root 2 times by 8 times by sine of 60. I'm just using a half AB sine C there. And that's going to give me the answer of 10 root 6. And they want the exact area, so I need to leave the roots in it. By the way, that is, I suppose you could, well, yeah, that's probably the nicest way of writing it. See, sine 60 is root 3 over 2. The over 2 changes that into a 4. The root 3 times root 2 is root 6. And then you've got 4 times a half, which is 2 times 5, which is 10. Find the length of AC. So this is cosine rule. If you like, AC squared equals 5 root 2 squared plus 8 squared b squared plus c squared minus 2 times 5 root 2 times by 8 times by the cos of 60. And then you just simplify that. You're going to get 50 plus 64 minus, we want this to 3 6 feet. So you probably would just dump this into your calculator and you'll get 7.58 to 3 significant figures. Make sure you round it carefully. Okay, number 2, what we got here? Another sort of sine cosine rule question. They like those questions. We've got to work out, now this one's a funny one, this first one. Calculate the shortest distance from L to the road. Now read the question carefully, note the typo there. The straight horizontal road is on A, B, and C. So if you want the shortest distance from L to the road, well, the shortest distance from a point to a line is always found by dropping a perpendicular, as they describe it. That's what we're going to have to do there. We're going to have to drop that perpendicular. That's what we really need for the shortest distance to the road. Now, if you think about it, what we've got here, shortest distance from L to the road, we've got, you know, what have we got? We've got that whole side. That looks pretty tricky to work with. I suppose I could use, could I use now? Yeah, if I can find this length here, then that would be really helpful. So if I could find LB or LA here, you could find either. Because if I've got that, then I can use basic SOHCAHTOA trig to find the perpendicular height. But this is quite a tricky question. I had to think about that there. I'm going to find LB. Yeah, let's call this side X. Yeah, I could say X, and just ignore the dotted line for the moment, and treat this like a sine rule problem. So I could say X over sin 65 equals, now you do actually know this angle, don't you? Because that adds up to 145, so that must be 35. So that's going to equal 200 over sine 35. And that allows us to find X. Now, that gives us X is 316.02. Now, once you've got that, now ignore the 35, drop your perpendicular, because what we're really trying to find here is this length here. Or actually, I'm going to draw this right angle on the other side. Just to show you, we've definitely got a right angle triangle here. And now this is a SOHCAHTOA problem, yeah? Because you're trying to find this, let's call this side P. You could say sine 80 equals opposite, which is P, divided by hypotenuse, which is 316.02. And now you can work out P, and you're going to get 200 times by, we're going to get 316.02 times sine 80. I'm just going to quickly do that on my calculator. And I get, oh, I'm in the wrong mode. Don't be in radians, don't be me. How do I change this into degrees? I always forget. And you get 311.2. And I think I've done this in a different way to the mark scheme as well, which I'm looking at just because this is the way which made sense to me this time. Hopefully that makes sense. That's quite a tricky question, that one. Okay, the distance LC. Okay, well, we already know this is 316.02. So let's write that on there. Let's call this side Q now. I don't know why, I just first letter which came into my head. We know that that's 100 degrees. And in these questions, this is a way to do it. You've just got to basically try and figure out, well, what angles can I work out from the diagram? Now, if you look at it, I've now got an angle and two lengths either side, so I can work out the third length using cosine rule. That's always the case. If you've got an angle and two lengths either side, you can use cosine rule to find the third side. So I can say Q squared equals 316.02 squared. Sorry, just trying to make it clear. Plus 200 squared minus 2 times 316.02 times 200 times cos of 100. Don't forget to square root that at the end when you plug it all into your calculator, and we're going to get 402.3. And there we go. Ooh, meters. Okay, number 3. What have we got here? Find all values of theta in the interval 0 to 360 for which cos of theta plus 75 is 0. Okay, this one's not too bad. We're going to have, now, you've got to be careful on these though. When you invert the cos, when you do inverse cos on your calculator first, which is fine for a first move, inverse cos of 0 is 1, yeah? Sorry, no, that's absolutely false. Cos of 0 is 1. Inverse cos of 0 is pi over 2. Oh, sorry, but we're in degrees. It's 90 degrees. So you calculate, when you press inverse cos of 0, it will tell you 90. Now, the rule of thumb for cos, I call it rule of thumb anyway. Whenever you do inverse cos, you need to do 360 minus first answer. Now, this is the way I see it, sine, cos, tan. Whenever you do inverse cos, whenever you do inverse cos, you're going to do 360 minus first answer on your calculator. I mean calc answer here, to find other answers. We get 270. That's equivalent to, on the cos curve, just noticing that basically, if you've got this one, then to find this one, because that goes up to 360, well, that gap is the same as that gap. And that's why we get our first answer, which, you know, it happened to be 90, it happened to be here, where you just need to do 360 minus 90 to find the 270. But it's always the same operation. And that's why I just remember a table of values like this. Now, the equivalent for sine and tan is 180 minus first answer. And tan is 180 plus first answer. Yeah, and that's just thanks to the symmetry on the diagrams. You might use cast for this. That's absolutely fine as well. After that, for sin and cos, just add or take away multiples of 360. So I just write 360s. For tan, you keep adding or taking away 180s. Tan is the easiest one to deal with. But that's how we work with these. Now, you might even be paranoid and add on 360 to 90 to get you 450, because you can always keep adding on 360s. But I don't think that's going to be in the range. I'm just going to write it down anyway, just to show you, you know, just put ... there. And then when you take away your 75, you're going to get 15 or 195. But when you take away 75 from that, you're not in the range. And so these are the only two answers that you've got, 15 degrees and 195 degrees. For part B, similar really. Sine 2 theta is 0.7. Invert that, you get 2 theta is, now inverse sine of 0.7 is apparently 44.4. Rule of thumb, sine 180 minus, so just do 180 minus that. That's going to give you 135.6. And then you keep adding 360s. Now do this before you divide by 2. I know you're tempted to divide by 2. Don't divide by 2 yet until you've done all of your, like, finding other answers for the symmetry and periodicity of sine. So 360 plus that is 404.4. And 360 plus this one is going to be 495.6. And then at the end, halve them all, because that's going to give you answers which are all in that range. So we get 22.2, 67.8. A lot of people will miss solutions here. So try not to, because obviously it's lost marks. 202.2 and 247.8. And there you go. That's all of the answers. It's hard to get all of those answers. That's why I'd say students miss some of the answers. Okay, the lengths of three sides of a triangle are 6.47 and 11.3. Okay, and we've got to find the largest angle. That's good. It's a bit of a thinker, isn't it? Because what would be the largest angle? Well, this one's the longest side, so I'm going to label that 11.3. And then we've got the other two pretty similar. They're 7 and 6.4. Well, let's put that one as 7 because it looks longer than this one. And this one's 6.4 centimeters. Now, which angle would be biggest? Well, the line which is stretching the triangle the most should be opposite the biggest angle, if you see what I mean there. And that's why we need this angle here. Let's call it theta. Make sure you're finding the largest angle in the triangle. So cos theta is going to be equal to, now it's this squared plus this squared minus that squared, and it must go in that order, yeah, because it's like the two sides which straddle the angle minus the side which is facing the angle, over 2 times 6.4 times 7. You're going to work that out on a calculator and invert it, and that's going to give you theta is 114.9. Yeah, and then find the area of the triangle. Well, now we can use this and just go area equals 1/2 times 6.4 times 7. I've got to use the two sides either side of the angle for the area of a triangle, times sine of 114.9. And that comes to 20.3 centimeters squared. Done. Okay, number 5. Given that tan theta is 5/7 and theta is acute, find, without using a calculator, exact value of sine. Okay, little secret, pro tip, if you've got one of sin, cos, or tan, just one of them, their value, then you can find all of the others without even bothering to find the angle. Students always want to press inverse tan and then plug that into sine. You don't need to. You don't need to, because just draw a little triangle, especially if it's acute. If it's acute, this is definitely the best way to do it. Draw a little triangle, because then this angle is acute, as in less than 90. Tan theta is opposite over adjacent, so that's 5/7. Now you can use Pythagoras to find this first side. That's 49 plus 25 is 74, square rooted, obviously. Yeah, so I'm just using Pythagoras to find that. Now I can find sine theta. Sine theta is going to be opposite divided by hypotenuse, and I get 5 over root 74. They're lovely, those questions. If it's obtuse, I think one comes up later in this homework, then I would probably use sine squared plus cos squared is 1, and I'd think carefully about the cos graph and sine graph and tan graph for when they're negative, because you might find, sometimes you find these are negative, not positive, when they start messing about with obtuse. Yeah, so watch out for that. Number 6. Okay, what do we got here? One of these complicated diagrams. Okay, so it's at B. Let's have a good read of this. So the lifeboat station's at A. A distress call is received and the lifeboat travels 15 kilometers on a bearing of 30 degrees to a point B. Suddenly they realize they've gone the wrong way and the lifeboat travels 27 kilometers on a bearing of 110 degrees. The lifeboat then travels back to station A. So angle ABC is 100. Well, this is one of those ones where you want to like gradually do it. Like, it's hard to kind of justify, but if I can describe it to you like this, I know that's going to be 30. And that's just because I've got a Z angle in there. Yeah, look at that Z angle. They're parallel, those lines. So that's a hard thing to see. That would be 70. And that's why angle ABC is 100. How do I describe that? I'd actually write it down in words. Like drop, I drop the dotted line. And I'd just say, like, look at this diagram. Drop the dotted line, 30 degrees because of alternate angles, 70 degrees because angles on a straight line, hence 100 degrees. But do draw a nice diagram and try and communicate with the examiner when they're doing that. So I would write, if you drop this down to a point, call that point D, I'd say ABD is 30 degrees. Reason, alternate angles are equal. And then I point out that DBC is 70 degrees. Yeah, if you want to know what to write down to get the mark there, and that's because angles on a straight line sum to 180. And you've justified it, sum to 180 degrees. Oh, one of my students has just walked in. Hello, Jessica. So I'm just doing a live recording, Jessica. I'll be 2 seconds. Okay. Find the distance the lifeboat has to travel to get back from C to A. So find this side here. Well, this looks like, once again, like a cosine rule problem, because we've got a length, we've got the angle in between. So for part 2, I'm just going to note that, let's call it AC squared. That's going to be equal to 15 squared plus 27 squared minus 2 times 15 times 27 times by the cos of 100 degrees. And so you can work that out. Once you crank it through, and don't forget the square root at the end, you get 33.1 kilometers. Now, part 3, find the bearing on which the lifeboat has to travel to get from C to A. My class are starting to arrive, actually. I'm going to stop this in one spot. I'm going to pause it. Don't worry, you won't notice a thing. But if I call that angle, well, let's just call it angle, what should I call it? Angle X, yeah? Okay, so I've got to find that angle. This feels like maybe a sine rule problem. I don't know, because I could say that this length, which I've just got, over sine of 100 equals this length over sine x, except I'll do it the other way around. I'll say sine x over 27 is going to be sine of 100 over 33.1. And then I'm just going to rearrange this by timesing that over there. I'm going to have to do inverse sine at the end. That is going to be worked out by my calculator. Make sure you're in degrees. Oh, 1,000, gone a bit farther. Over 33.1. Invert that, and you're going to get, I did it a different way here. I think you're going to get, let's have a look. I'll have to, because I've done it a completely different way in my mark scheme, but I've decided, it just goes to show you can do these in lots of ways. Don't think that my way is the only way. I seem to have used the cosine rule. Divided by 33.1. inverse sine of the answer, and I get 53.44. Now, what have I worked out here? I've worked out this angle, which means I now know this angle, because if that's 53.4, add the 100 to that, that's 153.4. So that's going to be 26.6, I think. And so what have we got here? Draw another north line up, because we need the bearing, which is all the way from here round to there. Well, we know that that plus that, if I can just drop another line in here, let's drop that down a little bit. Don't worry, class, I'm going to turn this off in a second. What do we got here? That's 110, and that's 70. So on this side, it's going to kind of go the other way around. This is going to be, this is hard to see, this is going to be 70. And I can work it out from that, can't I? Because I've got 70 plus 26, which is 96.6. So if I just do 360 minus 70 plus 26.6, quite difficult, that one. And that's going to come to 360 minus 96.6. I make it 263.4 or 263.5 they would have accepted. So if you have anything from there to there, that's good. Bear in mind, bearings always measured from north clockwise. That's the angle you're really, sorry, yeah, clockwise. That's the angle you're really finding here. Okay, I'll be back in just well, you won't notice at all. I'm just going to pause it. Okay, so where were we? Question 7, sine of 2x plus 50 is 0.6. Okay, we've got to solve that for 0 to 180. I think it's quite generous, 7 marks, to be honest, but I suppose there's some subtle things involved. Okay, so we're going to go, okay, I'm just going to write down sine of 2x plus 50 is 0.6, and I'm going to invert that by doing inverse sine. And inverse sine of 0.6 is 36.9. Now, resist the temptation to take away 50 and divide by 2 straight away. No, find all your answers first. So remember that rule of thumb table I showed you? Where is it? 180 minus first answer. That's the first thing you do. That finds the 2 principal solutions, which your calculator won't tell you. So that will give you 143.1. Let me just move the microphone slightly closer to me so you can hear me. Okay, what else have we got? Just realized I dropped the mouse. Oh, here we go. And remember as well, for both sine and cos, once you've got your 2 principal answers after doing 180 minus, or in cos's case, 360 minus, you then keep adding 360s or taking them away, actually. So I'm going to add 360 to that one. I'm going to get 396.9. I'm going to add 360 to this one. I'm going to get 503.1. And it doesn't matter if you go too far here, because you're going to soon realize that the answer's out of the range. You could, of course, double that and then add 50 to find out where the range starts. Now, the problem is this one is not going to give you an answer, because when you take away 50, you're going to be negative. And so you're not going to be in the range. It's not that it's massively wrong. It's just not right. Now, what I'm going to do is I'm going to take away 50 from that and divide it by 2, and I get 46.6. I'm going to take away 50 from that and divide it by 2, and I get 173.5. I'm going to take away 50 from that and divide it by 2. And then I'm going to get upset because it's actually bigger than 180. So I just get that answer and that answer. So I think it's quite generous, 7 marks for that question. Remember as well, anything you solve in maths, you can check. So plug this answer back in here, double it, add 50, press sine on your calculator, and hopefully it's very, very close to 0.6, because then you've definitely solved it. Okay, part 2. In triangle ABC, AC is 18, angle ABC is 60, and sine A is a third. Use sine rule. So this is one where you definitely want to draw it out, because I'm already confused. I need a picture. Okay, ABC. AC is 18. ABC is 60. And sine of A is a third. Okay, right. Well, and it's telling me to use sine rule. Now, I want to find this, like, or I'm going to label this. Sorry, BC is 4 root 3. And so what I can say is sine A over 4 root 3. And I'm just using sine rule because I'm doing as I'm told, like a good person. Sine A over 4 root 3 equals sine B over 18. but sine B is sine 60, sorry, over 18. And now I can find sine, oh, sorry, oh yeah, and I'm trying to show that that's 4 root 3. I apologize, can I start again? So with show that questions, I like to end up with the answer at the end and go, voila, hence it is true. So I'm not going to write down that 4 root 3. I'm going to just point out like this. Sine A over BC, sine A over BC equals sine 60 over 18. Sine 60 is root 3 over 2, so that's going to be root 3 over 36. So I've got sine A, oh, and that's a third, over BC. I'll show you how to do this without a calculator. A third over BC is root 3 over 2. It's the smallest square root. Divided by 18, yeah? I suppose we could cross multiply here. 18 times a third is 6. BC times root 3 over 2. Now I'm going to times that over there. It's going to be 12 over root 3 is BC. Times top and bottom by root 3. I get 12 root 3 over 3, which is 4 root 3. You see that? 12 over root 3 times by root 3 times by root 3. You're going to get that as the same as 12 root 3 over 3, which is 4 root 3. Done. Okay. Next one, 8. Find the values of theta to 1 decimal place. So this is a typical one. We're solving a trigonometric quadratic. We've got 3s squared minus 2s minus 1 equals 0. Because these are quadratics in disguise. Essentially what I've done here is I've let s equal sine theta. I like doing that in these trig function questions because it just means I write down less stuff. And now I'm going to try and factorize it. Hopefully it factorizes. I'm optimistic it will, because they normally do. If it doesn't, you just have to use the quad formula. And now if I go minus 1 plus 1, I think that works, doesn't it? Because I get plus s minus 3s. Well, that's minus 2s. Yeah, that looks good. So at the end, I can see that s is, if you like, s is minus a third. Or s is 1. Yeah, but that's sine theta. So I'm just going to invert that at the end. For sine theta is minus a third. First answer you get actually is minus 19.5. But then you do 180 minus, and you get 199.5. Because you do 180 minus 19.5, so you get 199.5. Now, unfortunately, though, that answer is outside the range, so we'll ignore that. But you could take away 360 from it, and you get minus 160.5. Because remember, once you've found your two principal solutions, minus 19.5 and 199.5, you can just add or subtract 360s to either of those values to try and make sure you get more answers in the range. But that's only going to give me those two, I think. And this one's just going to give me theta is 90. And so I get, sorry, I'm writing sideways here, but I get 3 answers there. Okay, now this one. This is about the periodicity of sin, cos, and tan. Now, you know I was saying you can add 360s and add 180s. That's exactly the principle I'm going to use in this question. You can add 360s to sine and cos because they repeat every 360. You know, look at sine, for example. Sine goes up and down, 360 degrees. And then it does the same thing again. That's why you're allowed, sorry, this is such a terrible diagram, but if you know that one there, it's going to have exactly the same y coordinate as this one over here. And that gap plus 360 is going to give you that value there because this is 360. Maybe it's easier if I notate it like that. You see what I mean? So from there to there is 360. Then from here to here is a gap of 360. So whatever this value is, add 360 and you get that. It works the same for cos. For tan, it's slightly different. It repeats every 180. So we just add or subtract 180s. What we're saying here is that tan of 570 is exactly the same as, right, take away 180, I get 473, 73, 90. But I could take away 180 again, and I get 180 plus 210. I could take away 180 again, and I get tan of 30, because tan repeats every 180 degrees. And tan of 30 is 1 over root 3. Done. Similarly for sine, I can add 360, yeah? So I'm going to get sin of 210, yeah? Now, sin of 210 is difficult, but with sine, you've actually got another really nice identity you can use. And this is because sine isn't a function. But here's 180 here, right on that bit there. Now we've got 210, which is like here. And I promise you that that will be the negative. That will be the negative of 150 up here, which is the same as sine of 30. Yeah. So if that is like a p, well, if that's minus p, then that will be positive p. And generally speaking, if you've got not tan, sine of 180, let's call it 180 plus x. This is quite an obscure one, this. Well, that is the negative of sine of x. In other words, if you add 180 to a sine angle, it will equal the negative of sine of the original angle. Let me give you a quick example. Sine of 30 is a half, but sine of 210 is minus a half. And that's why this one is going to be minus a half, because I know that sine of 30 is a half. That formula always holds true. Yeah. We can prove it actually with a compound angle formula, which is something you do in the second year. Cos of 210. Well, cos of 210, and this works similarly for cos as well, actually. Cos of 210, and you can see it from the symmetry of the graph here. If you're good with the graphs, you can see everything from those. There it hits at 90, reaches its nadir at 180, and then goes back up to a peak at 360. So that's 270. That's 90, and so on and so forth. That's be like 180. Well, they're at 210, which is about here. Yeah. That's the same as 150 because it's symmetrical either side of 180. So it's the same as 150, but you get that, that symmetry again. That 60 degrees there would be the same as cos of 30 up here, but negative. Yeah. So if this is minus p, this would be the same as p. This is hard to do without a calculator, and some people just memorize these results. But because of that, because basically cos of 210 is the same as cos of 150, which will be the negative of cos of 30. You know cos of 30 is root 3 over 2, and so this is going to be minus root 3 over 2. It will be the negative of cos of 30, and that would be minus root 3 over 2. And that's because cos of 180 plus x is the same as minus cos x, yeah? And you can see that happening there. Cos of 30 plus 180 is cos of 210. Well, they'll be negatives of each other. Okay, so that was quite difficult. It's the same as cos of 30, negative, and that is minus root 3 over 2. Cool. Okay, given that sine theta is root 2 over 5 and theta is obtuse, find without using a calculator the exact value of cos theta. So this is very similar to this one I did earlier, where I drew a little triangle. I can't find it now. Where is it? Here it is, yeah. Now, I said you can draw this little triangle when theta is acute. This little triangle and Pythagoras is your friend. When it's obtuse, you just need a little bit more thought, yeah? So I'm going to use this time the fact that sine squared theta plus cos squared theta is identical to 1. Now, sine squared theta would be 2 over 25. I've just squared root 2 over 5. And now I'm going to rearrange this to find cos squared theta. So cos squared theta is going to be 23 over 25. And so cos theta is the square root of that, which is root 23. And as I can square root the bottom, I will, over 5. Now, you might think, great, that's all I need to do. But there's always the sign issue. Yeah, the only way this can go wrong is you can get the sign wrong. Because remember, when you square root, you do actually get a plus or a minus. And we need to decide which one we need to use. Now, we can decide that straight away. Right? It's told us that theta is obtuse. Now, if theta is obtuse, and join the sine curve here, just to show you, when sine theta is acute or obtuse, you get the same values anyway, like but just symmetrical around 90. So theta, well, obtuse means it's from 90 to 180, yeah? Now, the problem is that cos theta is negative, and so it's the cos theta graph I really should be drawing to not confuse you. If we draw a cos theta graph, that actually goes negative at 90, and I'm not going to draw it all. I'm only going to draw half of it, just to show you that if it's obtuse, cos theta must be negative. So I have to take the negative root 23 over 5, just because cos is clearly negative when theta is obtuse. That's it, yeah, as theta is obtuse. So that's all you've got to worry about with acute and obtuse stuff. Probably some of the most obscure bits there in that homework are these two equations here. I'm suspecting you might not have seen that before. I don't know. But yeah, it really, you can get it from the symmetries of the graphs as well. Okay, hope you enjoyed that. Well done. Thanks for listening. And I'll see you on the next homework.